Okay. Let's see. So what you do. So yesterday we proved these properties together. We proved these three properties. So if you missed yesterday's lecture, you should probably take a look. It's never a good idea if you're planning to go into STEM field to not have a solid foundation of why rules exist. Why do they work? Why do they make sense? You don't want to ever just accept it. Just go, that's what he said, let's do that. No, because then you learn other rules that build off of rules like these. And the shakier these are, the shakier those are. Every single one of these rules makes nothing but sense. But not if you just look at it. If you just look at this shit, if I just showed this to you, you should say, what the shit are you talking about, Jeff? This doesn't make any damn sense. It doesn't if you just look at it. But if you derive it, like, oh, okay, when I divide things, I subtract the powers. Laws of powers, there you go. So how do I do that first one?
Log 3.
Yeah, since this is the division inside of a log, I can do log base 3 of 3 minus
base 3 of 5.
What's log base 3 of 3?
1.
And what's log base 3 of 5, of course? I don't know. Good. Perfect answer. So we just leave that one alone. Make the 3 a little mutant 3. It's okay. So it's a lot like square root of 20, square root of 4 times square root of 5. Do the square root of 4, don't do the square root of 5. It's not the same work, but it's the same exact idea, right? You do the part you can, you leave the part you can't. Part B is just part A in reverse, yes? And this is highlighting that, and I know I make this joke, and not everybody gets it, but I mean, math goes both ways, so be jealous. But if I have this, I can rewrite like this. If I have this, I can rewrite it like that. Yeah, somebody's shaking their head at me, it's okay. So how do I rewrite this?
Log base 5, parentheses, 75.
75
divided by 3.
divided by 3?
Yeah.
And what's 75 divided by 3? 25. And what's log base 5 of 25? 2, because 5 squared is 25. Bodacious. Okay. And part C is interesting. I could do that 2 different ways. Let's apply this directly. How do you rewrite part C just directly using this property?
Log base 10.
Yeah, log of 1 minus log 10. What's log 1?
0.
Good. 10 to the 0 power is 1. What's log 10?
1.
1. So what's 0 minus 1?
Negative 1.
Holy shit. Now another way to look at this, using this last property, is if I rewrite this like this, or not even using the last property, to be honest. Are you guys cool with that? 1/10 is 10 to the negative 1. And of course, then I could just say, what do I raise 10 to make it become 10 to the negative 1? I raise it to that. No, come on. What do I raise 10 to make it become 10 to the negative 1? Or, what do these do to each other?
They cancel out.
So the answer is negative 1 again. So, I mean, no matter what way I do it, it has to come out to be the same answer. And then I told you that all of these rules are important, don't get me wrong. But the one that we end up using the most is the last one. It just happens to be the one that shows up the most. So how can I rewrite this?
2 log.
Yes, the 2 can just come down. Bang.
1/2.
What about this guy? Yeah, radical notation sucks. It just sucks. So I'm going to make a point of it in this class. Very often we have to change from it. In calculus, you are always changing from. Radical notation is never good. You change it, and then you can do calculus to it. Again, that's why I wish we never created the damn thing. What's another way to write square root of x?
1/2.
X to the
1/2.
1/2 power, and then of course what can happen with the power?
It goes up.
Chapa! And then this guy, I purposefully put this here, especially because my whole rant just now about the square root and all that stuff. But I mean, what's the power on the inside of the log? What's inside the log is e, and what's the power on it? Square root of r. So what can I do with that power?
1/2.
No, I don't have to do that. What did we do with this power that was on the a?
We just put it in the front.
Took it down. What did it do with this 1/2 power that's on the x?
Took it down.
Took it down. So what do we do with this power that's on the e?
Take it down.
Oh, yeah. So that's one place where the radical isn't even part of what I have to worry about. So I don't give a shit. It is a power. It is on the thing inside the log, so it can come down. If you wanted to, you could rewrite it as r to the 1/2, but in this case, it doesn't really matter because I don't have to work with it directly. It's just move it. Who cares how it's written? Yeah.
Wait, so how would you differentiate between why this one you could move just down?
No. I did exactly the same thing here that you guys told me to do here.
Right.
What's inside the log? A. What's the power on A? 2. What can I do with the power? Bring it down.
Yeah.
What's inside the log? E. What's the power on E? This. What can I do with this? Bring it down.
Oh, well, this
It's
one.
exactly the same.
Got it.
Nothing different. Okay, I like it. Now, two things. These are kind of unsatisfying because you can't get a number. Let me show you a concrete, not a place you would use this rule, but just to show you it still works. What is this?
1.
Let's just do this directly. Yeah, wouldn't this just be log base 3 of 3, which is 1? Yes? Now, if I wanted to, how can I rewrite this? Square root of 9 is 9. Square root of 9. How can I rewrite it?
It's 3.
9 to the
3.
1/2 power, yes? Square root cuts things in half multiplicatively. You guys with me? What can I do with the 1/2 power?
You can move it to the front.
Again, this is nothing you would ever do, but I want to show you it still works. What's log base 3 of 9?
Oh,
2. And then taking 1/2 of that, what do I get?
1.
Same answer I got before. Now, obviously, we would do it this way, yes? But I want to show you that the property we just realized, the rule, works. It has to be consistent. If the rule was applied and I got a different answer, the rule needs to be thrown out. It has to be consistent. One more time, never do that problem that way. I just did it that way to show you it still gives you the right answer. Okay. Second thing, is there a difference between this and this? Are those different?
Yeah.
Hell yeah, what's being squared in the first dude? A. So what can I do with the 2? I can bring it down. Because the rule is, if the inside has a power, that power can come down. What's being squared in the second dude? The whole freaking thing! So can I bring the 2 down?
No.
Hell no. Okay, good. Why is he making such a big deal? I don't know, maybe it's a huge mistake people make in calculus. That happens often enough, you want to do. So the first one you could rewrite, and in calculus, this is huge. If you can take this and rewrite it like that, a lot of work becomes easier. And you'll see when you get there. This one, that's why students hope you could bring the 2 down, because then it would be easier, but too bad, you can't. So then you gotta do some weird shit. Okay. I'll lock it. Alright. So let me, I wish I would have, it's too bad, Jeff. It will be okay. Let me show you some more complicated beasts using these properties. So for example, if I have this, now, do we know a way to rewrite log base 3 of stuff minus log base 3 of stuff? Do we know when we subtract logs? Do we have a way to rewrite it?
Yeah.
Yes. That's not what that says though, is it? That says 2 log minus log. I ain't got shit that tells me what to do with that. You guys see that? That coefficient's in my way. If I can move that 2 out the way, I've got a rule that tells me what to do. Yes? What can I do with the damn 2? Instead of erase it and hope I don't notice. I could bring the damn thing up, because every property I could do either way. So why do I want to move that 2 back up? Because if I do that, then I have log minus log, and we have a property for it. You guys see that? So when I'm, the instructions in this would say, combine these into 1 log. That would be the instructions. Any coefficients you immediately just bring up as a power. That gets them out the way, yes? So if I bring that 2 up, now what can I do? Okay, well, how do I, what's log
Oh, yeah,
A
the
minus log B? What do I do with that? You could look at the worksheet, do you guys remember?
Rewrite the second one.
Say again? Yes, I can make log base 3, 1 log of the quotient, yes? When I subtract powers, I must have been divided. So this is a, log is a power, so that's power minus power. When do I subtract logs? When I divide. So I could rewrite this as 1 log of the quotient. Now, let's see if anybody can escape the trap I've set for you here. You could simplify that.
X squared? You cancel that X squared?
You, as sure as all hell, cannot cancel the x squares. You guys see why? What's the bar mean, of course? Division. And what is division the opposite of? So it will only cancel if it's involved in a multiplication, right? What's the operation on the bottom?
Subtraction?
Subtraction. That's division can't cancel parts of subtraction. That's not its job. Addition does that, not division. So you cannot cancel the x squares. That doesn't make any damn sense. Division is not the opposite of subtraction. How could they cancel it? So anytime you're about to cancel shit, just stop yourself and go, are the operations opposite?
Wait.
Yes?
Just trying, would it be 1 minus X? Because it's X squared.
Yeah, what can you do instead? How do you make the bottom become multiplication so then division can do its job? Factor it. What comes out? X. Now, how many x's cancel? 1. 1 of these cancels, yes? Bam. So as always, you know this is true. You know, and you know I'm like this too. I'll give you a problem that's got multiple steps. So maybe you do the first step correctly, and if you stop, once you put that log together, you can keep going, because now you've made a fraction, you can see if it reduces. Okay, let me stop for a minute. While you guys ponder that, who just came in? Is that, no, Henry? Yes. Alright, we'll catch you in a second. Somebody else snuck in, did they? Everybody else got their stuff back? Okay. Alright, so let's try this one. Okay, try to put that together into one log. And realize, why are we able to do that here? Why would we be able to do that? Same base, kick ass. They all have the same bases, they all work together, so you can combine them into, if one of those bases was something else, I couldn't combine them all into one log. Alright, go for it. So what's the first thing you guys are doing?
Open the power.
Yeah, so this coefficient can become a power and so forth. So I can rewrite this as log base W of
1/2.
a to the 1/2 plus log base W of 3/4 minus log base W of
7.
m to the 7. Cool. When I add two logs, that's the log of the multiplication product. And when I subtract logs, that's the log of the. So let me show you a shortcut. What's the only thing that's being subtracted?
7.
The last two. So here's a bit of a shortcut. I really want you guys to get this. These two would just multiply together, correct? Make some room here though. This times this. And of course this would divide. So the shortcut is when you have log plus log minus log plus log minus log plus log minus log, everything that's minus just goes on the bottom, everything that's plus goes on the top. Because that's what we do. We multiply when we add logs, we divide when we subtract logs. Yes, sir.
So when you're applying the power rule, you don't carry the sign?
Oh, you could. In fact, here. Wait, let me make sure everybody's got this. I'll do it the other way. Because you'll end up in the same place, won't you? If you bring a negative 7 up, you'll have an n to the negative 7 on the top, and that would flip. But I'll show. Somebody cool with this? So do you guys understand Ricardo's question? It's a great question. He's saying to me, all right, Matt, boy, I see a negative 7, man. So what happens if you bring that up? All right, let's try it again. What if, oh shit, Jeff, stop using this. Use your blank paper. What if I start here, and when I rewrite it as log base W of a to the 1/2 plus log base W of c to the 3/4. And here, I bring the negative 7 up. I didn't just bring a 7, I brought the negative 7. Are you guys with me? That is a completely valid way to do this. It better come up with the same answer, or else we could throw this out and go home. So, am I adding all of these logs? So then I can rewrite it as log of bam, 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 multiplied, right? That's the property. Is that the same thing I got earlier? Yeah, because that means do what to it?
Subtract.
Flip it. That means flip that, and then it's the same answer, yes? Both ways, perfectly valid. Kick ass. Kick ass. I'll show you even one more thing. Any questions on that one? Okay. Oh. You good? Okay. What about, oh shit, I just forgot what I was gonna, oh yeah, that's right. If I have this, This one's kind of silly. How can I rewrite this one?
Log 2 divided by x squared. X squared
X squared
over x.
divided by x. And of course that would be 1.
X.
Yes, because 1x cancels. Is everybody with me? What if instead I brought that down? Does everybody see what to do there? What does this say?
Same.
What does this say?
Power
Two.
of
2 log 2.
X. Power of X.
Yeah, this says 2 of these minus 1 of these is 1. So 2 log base 2 of x minus 1 log base 2 of x is 1 log base 2 of x. I get the same damn answer. So every time we develop rules and processes and functions, it's got to be internally consistent or the whole thing goes to shit. So if I have multiple ways to do a problem, they better all come out to be the same answer. Okay. So if I gave you the problem and said simplify this, could you do it either way? Oh, hell yeah. Yes?
Can you explain again how it still equals log 2 of x?
What's 2m minus n?
2 it's m
Yes, what's 2w minus w?
w
What's 2 nirvanas minus nirvana?
nirvana.
1 nirvana. So what's 2 log base 2 of x is minus 1 log base 2 of x? No.
Log 2 of
Log
x.
2 of x, yes.
Yeah.
2 of these minus 1 of these is 1 of these. That's the general rules. That's like terms.
Okay.
So in order for logs to be like terms, they have to have the same inside and the same base. Then they're like terms, you're going to put them together. Alright. So last thing for today. And then we have a mystical, magical early leaving for the spring break. Okay. Mystical, magical. Okay. Jeff, calm down. Of course, what we're about to get into is going to take about 30 minutes. So, no, I'm joking. No, we're just going to do 1 or 2 quick examples. Solving equations with logs and exponentials. So it makes sense. Once we learn a new function, we learn its inverse, we learn the properties of that function, and then we say, what if it wasn't an equation? How do I solve that equation? So one kind of equation is really silly. You can do it, Jeff. That is an exceptionally silly equation. Does anyone see how to solve it? Washing machine, kick ass. I love it. How do you get the x by itself? Well, if I rewrite it in exponential form, the x is by itself, correct? That's how I solve an equation, so I try to get the variable by itself. What would the washing machine tell me here? It would tell me
3 to the 4th.
3 to the 4th
is x.
is x. So what's x? What's it, 3 to the 4th?
81.
81, kick ass. 3 to the 4th is 3 squared times 3 squared is 9 times 9 is 81. So the last problem for the day. Last problem for the day. Here we go. And this one will only take, no, I won't even make the same joke again, I'm sorry. This one will be quick. Well, it depends. Let's see what you guys see. What if I have this? Oh shit, I gotta make one that works. Give me a second. Yes, okay, so if I do this, you can do it, Jeff. Yeah, hold on. I'm trying to make one that works. That would be, okay. Alright. That should work. What is different with number 2 up there?
It doesn't equal.
So did number 1. So what's different between number 2 and number 1?
No, I'm saying they have the same base.
I've got how many logs?
2 logs.
2! If I had 1 log equals number, I can do the washing machine. I can do what we did. Does anyone have any suggestions to help me so that I stop having so many freaking logs? Yeah, totally. There you go. Holy shit, there's, wait, There's a reason for those rules? Are you kidding me? Yes, okay. So now I can solve this because we know the quotient rule. This becomes log base 3 of?
X over X to the X minus 1.
Careful. Becomes 1 log of the quotient, yes? And now that problem, believe it or not, I know the inside is much worse, but who gives a shit? It's log base 3 of stuff equals 1. The first problem was log base 3 of stuff equals 4. So the next step I do is the same step. What's the next step?
Subtract.
No, come on. What did I do here?
You did the washing machine.
So what do I do here?
Washing machine.
3 to the
1.
first power equals? Now, do you guys know how to solve that? It does not matter what's inside the log. If it's 1 log of stuff equals number, you can always do that. And then you step back and go, oh shit, what have I done? How do I solve it? Yes, sorry.
Bottom multiply.
Yes! What sucks about this problem? What's the worst thing about this damn problem? What do you wish wasn't there? The division. Okay, how do you kill it? Alright, so see how... So I miss teaching my math 88 and my math 90. But you guys can hear this too. The great thing about solving equations is you just say to yourself, this doesn't always work, but you go, what do I wish wasn't here? Well, let me just kill it. Let me, again, not a life lesson. I don't want like 20 years from now somebody on the news going, my math teacher said it was alright just to kill people. I did not know. So if I multiply both sides by x minus 2, over here, these, now dear God, some people just don't cancel these, but that's the whole reason. So what's on that side?
X.
X. And over here I get 3x minus 6, and then this is easy as shit. So it's 2x equals 6, I get x is 3, which is exactly the answer that I used to create the problem. What's one thing you have to be careful about, do you think? I should have made a problem that had an issue, but we'll do that next time, I guess. But what do you have to be careful about? What kind of inputs can logs not handle? Sorry? Oh, because subtract x to add, I just, right? Get your x's together. Subtract x, add 6, okay. Don't just look at what I did, do it. And then you'll see, oh, that's what I did, okay. What kind of number? What's the only kind of numbers that a log can handle? You can do it. What's a logarithm look like again? Like this, and what's this? Like it looks like this, yeah? So what's this? Where is it? X equals 0. So what kind of inputs are the only inputs logs can handle? Positive. So if you get if the answer here, well, the answer is 3. Does it make either of these negative?
No.
That's 3, that's 1, yes? If our answer would have been 1, then he's fine, but he would have been negative, and we would have to throw it out. Just like with square root stuff, right? When you solve a log equation, you have to make sure the answers you get don't make the original problem freak out. Okay. So let me ask you this. Do you want to see a problem real quick where that happens? And then we'll leave. Okay. What I love about that is, if you said no, we were going to leave. So I love that you guys voted to stay for a little longer. Which makes me all giddy inside. I'll be all right. Let me see if I can do this. Oh shit, can I do this? Shh, I don't know. Okay, let me force this to work. Let me see. Scheisse. Let me think about it. And then you can do it, Jeff. Wait. And then let's just do this. Yeah, okay. Alright, let's see what I've created here. Oh shit, I'm a little concerned. It'll be okay, Jeff. And then that should be, oh, no. I'm sorry. I need this to be, sorry. Make this like this, and then that should work. Let me double check. Yes, that should work. Okay, that should work. All right. Alright, so let me write this a little bit better. Just to make sure we're all on the same page. And let's see if Jeff actually makes something that work. That would be great, Jeff. So what's the first step?
Make the log into one.
Yeah, the number of logs is too damn high. So we force these guys together. How do we do that?
X plus 1 times X minus 1.
And then
Washing machine.
washing machine. So 4 to the first, and then you would multiply this stuff out. As I'm just going to kind of cut to the chase a little bit. Because what do I need this to equal to be able to continue? Since it's a higher power than 1, I have to have it equal 0. So then I can factor and get the answers, correct?
Mm-hmm.
All right. So I'm going to subtract 4. So then I get x squared minus x minus 6 equals 0. Can I factor that? Yes. Good. Thank God. I was hoping I made one that worked. X minus 3. X plus 2. So what are my two answers? 3, negative 2. When I plug a 3 in, does it make either of these negative? No. When I plug a negative 2 in, it makes them both negative, yes? So therefore, what do I do with this answer? Cancel it. So the only answer is that one. I got an extra answer. Now, why did I get an extra answer? We did every step correct. Because when x is negative 2, stay with me now, watch this. When x is negative 2, isn't that negative? And isn't that negative? Yeah. But what did we do? The first thing we did was we multiplied, what's negative times negative? So this equation has those answers. This equation only has one of those answers. When we multiplied those together and we had to be able to get any answer, we introduced another answer. That answer works here, it doesn't work here. I really want to make sure, because students already don't like math, and then they do a problem perfectly right, and one of the answers doesn't work, just because. So that could be frustrating, but in order to get any answers, we had to allow some wrong answers. That's the only way to get any answers. So then we have to, as the humans, we have to go, oh shit, throw that one out. Maybe. That's enough, okay. Have a good break. I am definitely going to have a good break. I will see y'all afterwards.